So our first terminologies that we're going to kind of look at is, so here we have a data set, okay? It's the students' grades on the last quiz. And again, please know that this is not actual. This is not real. So this set of number, right? These set of numbers would be our data points, okay? So the students' grades were, we got one person had a 0, one person had a 50, 60, 60, 70, 70, 70, 80, 80, 90. Okay. Now, the first types of stats that we're going to really talk about are mean, median, mode, and range. And hopefully that's all very familiar with you guys. Okay. So first type of number that we're going to talk about is called the mode. Okay. And the mode is the most frequent number. Okay. So what you want to look at is look at our data set. Okay. And we were looking for the number of times, right, that that each number kind of appears. Okay, so 0 and 50 both appear once. 60 appears twice. 70 appears 3 times. 80 appears twice, and then 90 appears once. So, out of all those numbers, which one's our most frequent number? 70, right? Because it appears 3 times. So in this example, our mode, right, would be 70. Okay. Now the median is the middle number, but this one can get tricky, okay? Because the most important thing that we have to do is we have to organize the data from least to greatest. And you should always practice doing that either way, okay? So since this data is already organized from least to greatest, if I want to find the median, right, I have to look for the middle number. Now the median, we're going to use terminology here to kind of indicate this. We're not just going to, when we're kind of talking about it, we're going to call our median, we're going to call it Q2. And that'll make sense in a little bit later. Okay, so our median is what we're going to call Q2. All right, and so if I'm looking for the middle number, right, I got to look at, okay, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Okay, so which of these is in the middle? Right? So what I'm looking at, so how do I find, right? How I find where the median is, the first thing I want to look at is my n. And so our n, whenever we're talking about it with our data, is the number of data in the set. Okay? Number of data in the set. Right? In this case, since we have 10 data points, n is equal to 10. Right? Now, to find the position of Q2, the formula that we're actually going to use, right, is n plus 1 over 2. Okay? Plus 1 over 2. So you can see, so now since I know n is 10, 10 plus 1 over 2, which is 11 over 2, which is 5.5. Okay? That's telling me, right, that where my Q2 is between 5 and 6. Now, when this number is even, as n is, in this case, obviously you can see that in the middle is I actually have to find, right, what 5.5 is. It's actually not part of my data set. Right? So what I have to do is I have to find the average between the 5th and 6th term. So, since they're both 70, right, my Q2, right, is 70. Because 70 plus 70 divided by 2 is still 7. Okay? So in this case, Q2 is equal to 70. Now, when we're looking at this data set, we notice that, right, that 0 it's kind of rough, right? It kind of makes things a little bit rough here. So let's pretend for a minute that we didn't have 0. So let's take out the 0. If I'm looking at this now, right, if I want to find the median or find Q2, I know my number of data sets is 9. Right? Then the position of Q2 is equal to 9 plus 1 over 2, which is 10 over 2, which is equal to my 5th term. Okay? So if I count 1, 2, 3, 4, 5, sorry, 1, 2, 3, 4, I counted wrong. Sorry. 1, 2, 3, 4, 5, that would be my Q2, okay? Be my 5th point. And again, you can kind of see that because I have 4 data points over here and 4 data points over here. So if n is odd, our median's always going to be the dead center, right, of it, and it's going to be part of our data set. But if n is even, so we do include the 0, then then we have to find the average. Okay? All right. The next point of data that we want to talk about is one that you're definitely all familiar with. Okay? Definitely all familiar. And this is the mean. Okay? The mean is the average of all the values. Okay? Now, before I kind of talk about how we find the mean, all right, we're going to introduce some new terminology. So whenever you're like checking with books or online or anything like that, there's 3 standard variables that we use to represent mean. Okay? So our first one is just simply a lowercase x with a line above it. Okay? Another way that you might see it is an uppercase X with a line above it. And then the last way you might see it is this Greek letter mu, right, which just looks like an oddly cursive M. Okay? And those are the variables that we use to represent the mean. Okay? The one that we're going to work with is the lowercase x with a bar above it. Okay? Now, another little terminology that we're going to introduce, all right, is sigma. Okay? Is sigma. And sigma, all it means is sum. Okay? Now, normally we would, in Algebra 2, we would talk a little bit about sigma notation, but that's now saved for pre-calculus. So if you are in pre-calc, you'll get a little bit more in-depth look at sigma notation. But all it means is sum. So the term, like the symbols we're going to use, if I see something like this, if I see sigma x, all this is saying is the sum of all data. Okay? That's all it's saying. Okay? So in order to find the mean, the formula we use is the sum of all my data divided by the number of data points. Okay? Now, again, we're going to look at this. We're going to include 0 first in our data. And you're going to see kind of what really happens here. So we're going to include 0. So the formula how we would calculate this is my mean is equal to the sum of all my data points. So I'm just going to add them all. 0 plus 50 plus 60 plus 60 plus 70 plus 70 plus, oops, 70 plus 80 plus 80 plus 90 all over, since there are 10 data points, 10. Okay? Now, that's why we use the sigma notation, because writing that out was just, it's taxing. And if we get like 50 data points in one set, that would be a pretty much a nightmare to try and calculate, or to try and just write out for the sake of writing it out. Okay? So that's why we use the sigma notation. Okay? Now I'm going to save you guys some time, and if I add up all of these values, I'm going to get 630, and then I'm going to divide that by 10, giving our mean as 63. Okay. Now let's look at what happens when we go without 0. Okay. So if I take 0 out, of this data point, or this data set, then my mean is 50 plus 60 plus 60 plus 70 plus 70 plus 70 plus 80 plus 80 plus 90. But instead of being, since our n is no longer 10, our n is now actually 9, I just divide it by 9. And so this becomes 63 over 9, which is equal to, 630 over 9, which is equal to 70. Okay? So without 0, you can see, right, that 0 has such a huge, just one data point has enough effect on this thing to lower the mean by 7 values. Right? By 7%, our tests are lowered because of that one test. Okay? This is what we call, and again, we're going to go more into detail about how to specifically find these, but this value is what we call an outlier. Okay? That 0 is a value that is substantially different from all of the others, right? And it skews the data. And we'll talk about skewing in just a moment. Okay? And again, we're going to go more into detail on outliers in a little bit later. Right? But for right now, just understand that it's a data point that really just messes up our data. Okay? So, the next thing that we want to talk about before we get into more of that is the range. Okay? Is the range. Range is the difference between the highest and lowest value. Okay? Difference between the highest and lowest value. So, what the formula looks like for this is our range is going to equal, and again we're going to introduce new terminology, Q4 minus L. Now, what is Q4? So we said Q2 is the median. Q4 is our maximum value in our data set. And L is our minimum value in data set. Okay? And to show you kind of how outliers, again, really massively affect the data, we're going to look at, okay, what's the range, right, with 0 in it? Okay? Well, the range with 0 in it, right? Q4, my highest value is 90, but my lowest value is 0. So my range will be 90 minus 0, which is 90 units. Now, if I take out 0, my highest value is still 90, but my lowest value is now actually 50. Okay? So my range now becomes 90 minus 50, which is equal to 40 values, okay? So one number has such an impact on the range that it changes it by 50 points, okay? That's huge for one number to have that much of effect. That's why it's an outlier, okay? And when we're doing outlier and when we're working with data, right, we actually don't consider outliers, okay? And the reason why is because, for example, in this case, how do we know that this person, like this test, right, why does it doesn't really help us, because what happens if this person that got a 0 just didn't show up? They didn't actually take the test. So when I'm sitting there analyzing and figuring out, okay, was this a good and effective test, right? That one person giving me a 0 is going to completely skew my data, and I'm not really going to have a good sense of how the entire class who actually took the test actually did. Okay? And those are just kind of examples of how outliers really negatively impact us. Okay? So, what we're going to do with our data is we're going to, and again, just to point out a little bit more clearly how an outlier affects it and what we mean by skew and stuff like that, is we're going to look at this data in what's called a histogram or a frequency chart. They're basically the same thing. There's some subtle differences, but essentially they're the same thing, okay? So the frequency is just how many times the data occurs in a set. So what we're going to look at is a chart which tracks the frequency of data. So I'm going to look at my table of values or my data, and I'm just going to mark them on my frequency chart, okay? So my first one, again, we're going to look at what happens with 0. My first data point is 0. So I just put an X above the number line at 0. Okay. Our next value is 50, so I'm going to go all the way to 50. I'm going to put an X above that number. Next number is 60. And then the next number after that is also 60, so on top of it, I'm just going to draw another X, okay? And then I have 3 70s, okay? 2 80s, and a 90, okay? So how a frequency chart or how a histogram helps us is a lot of things. One is now you can tell me which of these is the mode without having to look at the data. Which one's the mode? 70 is clearly the mode, okay? And this gives us an insight of where any outliers or what the shape of our data really is, okay? So clearly 0 is an outlier because if I look at where all my data is, this guy's off on its own. It's kind of outside of where everything else is. That's one of the ways we consider it an outlier, okay? The histogram of the frequency chart also tells us, or gives us a general shape of what our data looks like. Okay? And if we didn't include 0, look at that nice looking curve there. We'll talk more about that later. Okay? Well, that's the kind of things that it can help us look at. Okay? Now, so that's it for kind of mean, median, mode, and range. So now we're going to look at maybe some new ideas. Okay? So this is what we're going to call the 5-number summary. Okay? So again, we're going to use the student grades on the last test. We're going to use the exact same data. Right? And now we're going to divide them up into what we call quartiles. Okay? And quartiles are the values which divide the data into 4 equal parts. Right? They're not always whole numbers, and most of the time they're not actually even part of our data set. Okay? And again, quarters, 4. How many quarters make $1? 4. What's 1/4 of something? 1/4. So essentially we're dividing this data up into 4 even parts. Okay? So the values that we're going to use are Q1, Q2, Q3, and Q4. Okay? Q1 is the max number of the lowest 25%. Right? Another way of thinking that is it's the median of the lower half. Q2 we already said was the middle value, or a median. Q3 is the median or the max number of the 50 to 75%, or it's the median of the upper half. And then Q4 we've already talked about is our max value. Okay? So looking at this guy, okay? Looking at this guy. All right, we know already that our median, we know some values already. Okay? This first value, right? This is our L. Right? It's our lowest value. Okay? Our minimum value. We know 90, no matter what, is our Q4, our max value. Okay? Now, since we're including 0, right, we know that it's between 1 and 2. We know that this point right here, right, this 70 in between these two, this is our Q2. Okay? So now the question is finding Q1 and Q3. Okay? So the tough part is we kind of have to figure out where these guys are. So again, like I said, for finding data, we're going to look at this now without 0. Okay? We're going to start off by looking at that. So if we're not including 0, 50 is our lowest value. 90 is still our highest. And we actually have 2, 3, 4. Our fifth value here, this is our actual Q2. So now this is part of our data set. Okay? And we're going to see that depending on how, including those values is really going to impact us. Okay? So how we can find them, if I want to find Q1 and Q3, is I can find, I need to count. Okay? That's the easy, quick and dirty way, is I just count. But key note, when I'm doing this is why I wanted to include this. If 70 is included in my, is part of my data sets, we actually don't even look at that value. So we don't include median. Okay? So now when I'm looking for Q2 or Q1, right, I can see, well, there's 1, 2, 3, 4 points of data that I'm looking at, which means it's somewhere in between these, which means it's actually between the second and the third one. So it's actually the average of these two, which would make it 60. And we can do the same thing for here, right? The average of those two is 80, and this would be Q3. Okay? So that's just kind of by counting. If we wanted to find it algebraically, right? It depends on what n is, okay? So if n is even, so 10, right? For example, then the position of Q1 is equal to n plus 2 over 4. Okay? So again, we're going to look at this going, okay, let's look at an even one. Okay? If n is even, here we have L, here we have Q4, and Q2 is Q2. Okay? We're going to say, okay, now if n is 10, we have, so we're using our example, we have 10 plus 2 over 4, which is equal to 12 over 4, so it's in the third position. Okay? So if we included 0, it would have an even one, and our Q1 would be our 1 to third value. Okay? And this would be Q1. And the same thing going over here. Now we're starting on, so it's basically you do the same, you count the same number from the median this time. Okay? to find Q3, I'd go 1, 2, my third one from the median is going to be Q3. And that's how you do it if n is even. But we're taking 0 out because 0 is an outlier. We said, oh yeah. 0 out because 0 is an outlier. So now we need to look at what happens if n is odd. Wait, n is odd. Because now n, there's 9 values that we have to consider. So if n is odd, the position of Q1, right, is going to equal n plus 1 over 4. Okay? So again, depending on whether n is even, when is odd, is going to change how we find it. Okay? So in this case, so for our example, right, our n is 9. So we have 9 plus 1 over 4, which gives me 10 over 4, which is equal to 2.5. Okay? So that means the position of our median of our Q1 is 1, 2, and then halfway between would be right here, like we showed earlier by counting, which is over here at 60. And so this would be Q1. And I would do the same thing over here, 1, 2.5 at 80. This would be Q3. Okay. Well, again, it just kind of helps us find those pieces of data. Now, again, we talked about the 25%, 50 to 70%, so on and so forth, right? So the nice thing about breaking it up into these quartiles and finding what these values are, right, is it tells me where my data is, okay? So what this means is that from here to here, oh, geez, that was terrible. Between L and Q1, no matter what, 25% of my data is. Okay? And it's going to be the same thing from Q1 to Q2. 25% of my data is in here. From Q2 to Q3, 25% of my data is. And Q3 to Q4 is also 25% of my data. Okay? And again, knowing where these quartiles are also allows me to do other things too. Okay? More than just 25%, 25%, 25%, 25%. It also tells me that, hey, you know what? Between L and Q2 lies 50% of my data. And from Q2 to Q4 also is 50% of my data. But even more, if I look at from Q1 to Q3, what percent of my data is that? It's 50%. Okay? But if I also looked at, let's say, Q1 to Q4, in this case it would be 75%. Okay? So just looking between those points tells me where a lot of my data is. Okay? I'll erase the 75%. Now that 50%, the Q1 to Q3, okay? Because again, I know that lower half is be 50% of the data. I know upper half would be 50% of our data. But that's not really going to tell us a whole lot of vital information. What I want to look at is I want to look at the chunky part, like the meat of our values. I want to look at that 50%. Well, how do I find that? Well, I know it's between Q1 and Q3, okay? So this leads us to our last new definition for today, is interquartile range, okay? The interquartile range, all right, is essentially just the difference between Q3 and Q1, okay? So in other words, oops, I don't want to use that color. The interquartile range is equal to Q3 minus Q1. And so this is going to tell us how much spread 50% of our data covers. Okay? So in this case, our IQR is Q3, which is 80, minus Q1, which is 60, which is 20, which means that 50% of our data covers only 20 different values. Okay? So again, it's kind of like analytics here. Essentially that's what we're doing. We're analyzing this data. Okay? And so 20, that means that the others, because again, our total range was 90 if we're including 0. If we're not including 0, it's 40 values. And still 50% of our data lies between just 20 small pieces of value. Okay? That's an important piece of information. Another way to visualize this, again, and another way that you're going to be able to visualize the difference between an outlier or not, is creating what we call a box and whisker plot. Okay? So, how to do a box and whisker plot for each set of data. Very first thing I'm going to do is I'm going to plot, right, L, Q1, Q2, Q3, and Q4. Okay? Notice how there's 1, 2, 3, 4, 5 data points that we're plotting. Why is it called a 5-number summary? Ta-da, same thing. Okay. So I'm going to plot L, Q1, Q2, Q3, Q4. So again, not including 0, right? Not including 0, we're going to plot L, which is 50, and all I'm going to do is I'm going to make a little dash. Right? Oops. That's L. I'm going to do the same thing for Q1. Q1 is at 60, so I'm going to make a little dash at 60. Q2 is at 70. We'll make a dash at Q2. Q3 is at 80. Oops, keep doing that. And then Q4 is at 90. So I have all my 5 points of data. Okay. Then my second step for doing a box and whisker plot is draw a line from the center of L to Q1 and Q3 to Q4. Okay? These are what's going to create our whiskers, so to speak. So from the center line of L, I'm just going to draw a straight line from it to Q1 and meet in the center. Okay? I'm going to do the same thing from Q3 to Q4. Okay? Our third step is draw lines to connect tops and bottoms of Q1 through Q3. Okay? So I'm going to connect the tops of Q1, Q2, Q3, and I'm going to connect the bottoms of Q1, Q2, Q3. Okay. Notice here we have a box, right? Is our third step. And also notice that our box encompasses only the interquartile range. Okay? So, I'll erase this in just a second. So this box represents our interquartile range. Okay? And you can even write this as box. Okay? So the nice thing about this right, is again, this tells us that this whisker contains 25% of our data. This one little box over here contains 25% of our data. This other little box contains 25% of our data. And this last whisker contains 25% of our data. Okay? And that's how box and whisker plots can help us. Okay? But now let's compare if we actually included 0. Okay? If we actually included 0, then what I'm going to do over here is I'm going to recreate our data points, and I'm going to find out our 5-number summary. Okay? So we have 0, 50, 60, 60, 60, 70, 70, 70, 80, 80, 90. Okay? And we know that our total number of data points is 10. Okay? So first thing I'm going to find is my lower point, which is L1, which is L, which is 0. I'm going to find my upper point, which is Q4, which is 90. So 2 of the points are already done. Okay. Now to find, let's just go Q2, at least the position of it. All right, I'm going to go n plus 1 over 2, okay, which in this case is 10 plus 1 over 2, which is equal to 5.5. So I'm going to go 1, 2, 3, 4, 5.5, right? And this is going to be the average between these two values, which in this case is 70 plus 70 over 2, right? Which is equal to 70, equal to 70. Our Q2 is now 70, okay? So Q2 is equal to 70. Now we got to find Q1 and Q3. Now since n is even, right, to find where Q1 is, we're going to go, again, the position, we're going to go n plus 2 over 4, which gives me 10 plus 2 over 4, which is 12 over 4, which is equal to 3. Okay? So our third data point right here is Q1. And we're going to do the same thing on the other side. Our third data point so Q1 is equal to 60, and Q3 is going to be equal to, so again, from the median, I'm going to count my third one, 1, 2, 3, and this is Q3. So now I have all of my 5 points. I'm going to go ahead and plot them. Ooh, well, I don't know why I did that. So we had L, which is at 0. We had Q4, which is at 90. We had Q2, which is at 70. We had Q1, which is at 60, and Q3 at 80. Okay. Now I'm going to connect my whiskers from L to Q1, from Q3 to Q4. Then I'm going to connect the tops from Q1 to Q3, and bottoms from Q1 to Q3. So again, look at our data now compared to when we didn't include 0. Our data when we didn't include 0 looks nice, neat, compact, and looks fairly even. It looks very symmetrical, right? But now with our outlier, right, we can see that it is not symmetrical. And that one of our whiskers is so much longer than the others, but the thing that's still true about it is that still 25% of my data lies like within that whisker. And then 25% of my data was within here, 25% is within here, and 25% is within here. Okay? So lots of different things in here. Okay? Lots of different things going on in here. All right. Do you have any questions? And so that's how we can do box and whisker plots. That's how we can do mean, mode, and range, and that's how we find our 5-number summary. And again, it tells us a whole lot of information. Okay? All right. So I'm going to go ahead and stop recording, and then you guys can go ahead and work on the assignment for today.